everyone, this is Steve Bishop from ProgrammingMadeEasy.com and of course Gartman Technical Services at GartmanTechnical.com. So today I've got another in my opinion video for you guys, and again this is where you guys have the opportunity to ask me whatever kinds of questions that you want. It does not have to be technical related. I keep telling you guys this, but of course all the questions that come to me are technical support related or software development related or database related. There's a few fringe questions here and there, but I'm telling you guys, anything you want to ask me, just go ahead, drop it in the comment section below. If it's one that's a good one, I will definitely get to it, okay? I just add it to my list of upcoming topics. And speaking of which, my list is actually starting to get a little short now. So I really, really need you guys to contribute and send me those questions, okay? Just drop them in the comment section below this video. And like I said, I'll add it to the list, okay? So today's topic, this question comes from Benjamin Cross, who asks, "Hi Steve, I like your video discussing the future of Access and would like to request another in my opinion video, which discusses your view on the future of databases in general. Anything like possible future changes in the way we store information, RAM versus disk, or new software or languages that are better suited for database management if there are alternatives to SQL and Oracle that make improvements to database management, or even alternatives to the relational database model that are on the horizon, if there are any. I ask because we can get bogged down in day-to-day programming projects and forget to invest time into learning and improving a possible better option. Thanks so much for your insights." Well, Benjamin, thank you so much for your question. I really appreciate it because, again, without your questions, I have nothing to make a video about. So I really need you guys to send those. So Benjamin's question is pretty good. And I admit I'm not doing a ton of research. I'm not going to throw a bunch of different websites at you guys or a bunch of technical terms because I think that this idea that SQL might go away or there's a better solution or there's a better alternative out there, it's kind of been knocked around for a while. But SQL's been around for a couple of decades now at least. It's not really gone anywhere, and there have been a lot of there are a lot of other storage solutions that are out there, like just storing on a hard disk as far as a text file. I've seen other systems where you actually store things in GitHub and retrieve off GitHub as an API, right? Kind of a file storage there. There's solutions that are kind of out there. Like there's no specific reason why you have to use a database to manage your persistence of your data. So why do we keep doing it, right? Why do we keep doing SQL? And I think there's a few reasons why. First and foremost, SQL, the language that we use to query databases, is pretty unanimous. I mean, it's used everywhere in all of the database management systems. If you learn SQL and Access, for example, there are some syntactical differences between Access and T-SQL, but they're kind of minimal. Like if you know Access, you know basically like 80% of T-SQL. And that goes really across the board for all of the relational database management systems that are SQL based. So you've got, PostgreSQL, MySQL, Oracle, you name it. If it's a SQL database, you can use basically your skills and your knowledge about how you access SQL and how you write those queries and update data to those to the databases. That's pretty universal across all those different platforms, with some syntactical differences, like I said. So it doesn't take a lot for you to shift databases that you understand and manage. There are some different ways, like Oracle's really a behemoth in order to try to manage. It's much more complicated, I'd say, than Microsoft SQL Server in the management department. But as far as the querying, updating, your CRUD actions, creating, reading, updating, and deleting, it's all pretty much the same across the board. And because there's this standard, why would we go anywhere else? Why would we try to come up with a new standard if what we have already works? And the only reason why you might do something different is if you can come up with something that's better. And it's so much better. It's such a big improvement that everybody just says, wow, we got to stop doing what we're doing, and it's just better for us to go this way. Now, this kind of brings me to NoSQL. NoSQL is an interesting alternative to the SQL databases that are out there, but you'll find that it really hasn't, it's not really gaining a big market share in the data persistence arena. There are definitely some good reasons to use some NoSQL, but frankly, it's their upside does not necessarily bring about a good reason to make a change within an application that's already existent. And really, the skills that people have already learned are around SQL, that trying to go do NoSQL makes very little sense for them unless it's a very special greenfield project that, you know, they really want to boost their performance, and that's what's really, really important. But there's such good there's already such good tooling with Microsoft SQL and other SQL databases that the speed at which you can do transactions is not a huge performance hit when you consider how easy it is to upscale your equipment, right? If you have hardware that makes the data transactions lightning fast, why would you need to go to another technology? If the whole reason to go to that other technology is to have an increase in speed and performance. But SQL databases are already having such a great performance because you manage it properly. Why would you need to make the change? The only reason why you would is if you're doing like a startup company, you're looking for some free solutions that are quick. And then maybe the NoSQL arena with like DocumentDB would be a good solution for you in your application. But again, if I am running a major software application like in an enterprise situation, it's very difficult for me to come to a good reason why I would switch from SQL to a NoSQL. Why would I go from Oracle to DocumentDB? And then I'd have to completely change a bunch of the logic that I might have in my application, especially because there's probably a lot of legacy code in there that relies upon it being a SQL server. So that's kind of why I don't think that SQL is really going to go anywhere for quite a while. And I'm also going to tell you that I think there's a good reason why SQL has been so persistent and why it hasn't gotten knocked off of its pedestal. And that's because SQL makes sense. Storing your data into tables and then having relational mappings between the different objects is just, it's an easy thing for us to comprehend. Our brains get that. We can easily say, okay, I have a person, so I'm going to make a table called person. That person, there might be customers, okay? So that person might be a customer, and here's their information. Well, their information is addresses, and an address is a separate entity, and then phone numbers. Well, those are separate entities too, and then all I need to do is just kind of set up the relationships between all of those different entities. That's a very logical way for us to manage how our data gets stored, and we get it. It's, I'm not going to say it's intuitive, but it's very easily learned, right? Whereas those other storage systems, they're not so easy to learn. They're a little bit more difficult to grasp. So I think that's one of the main reasons why SQL is so ubiquitous. And even if you think about how we do object-oriented programming, it's in a very similar manner to how we do data storage in tables. We have these classes that encapsulate everything about that particular object, the properties and the methods. Now, SQL databases don't have methods on them, but you can do triggers, and you can do stored procedures, you can do functions, and then you can trigger those functions and stored procedures. But for the most part, having this encapsulation of information into a single entity is precisely how we like to organize our data, how we like to compartmentalize things and organize our thoughts and the things that we work with. So that is precisely the way that SQL manages data in very easy to organize and orchestrate entities. So if that's the way that we do it in object-oriented programming, and that's the way we do it in SQL Server, why would we try to split this way that our brain works? Why would we try to go into some other direction? So it's really kind of one of those existential questions. It's not necessarily a one that's really founded in any real need in the market, right? There's no need in the market to go away from SQL and find a much better solution, because SQL is already a great, fantastic solution to the problem. So why would we move from it? I think that's probably the main thing. So as far as RAM versus disk, now this is a good one, because I think there is some room for having more memory style systems. I still think that SQL as the language to ask is really, really the solution. Like SQL, SQL as the language, like T-SQL, is probably still going to be the main way that we would like to access our data and store our data. But as far as the actual storage, like bits and bytes onto a hard disk, this has been kind of one of those areas that I think like RAM is obviously much faster. We've gotten to solid state drives, which is really, really fast. And because of that, that's really helped SQL a lot, having these solid state drives, because you don't have, those little arms trying to find the little bits anymore. So we have much faster hard disks now. And as long as we continue in that direction, there's really no need for us to move into RAM. But I do think that with systems being up, if we have computer systems that we can say that are redundant and have backups, but they're always on, right? If we have systems that are always on and then redundant systems and they're always up and running, why couldn't we store all of our data in RAM? And RAM is starting to get fairly big, right? We can get, 64 gigs of RAM fairly cheaply. 64 gigs of RAM on a server seems like, a bit much. But now that we've broken that 64-bit barrier, it really helps so that we can put a ton of RAM in these systems. But that is essentially where you can start storing your information, is in the memory, so that it's always immediately available. And you can imagine if I had a server that was storing its information directly in memory and made it accessible from memory through like a SQL language, then the speed at which I'm going to get that information is lightning fast, right? It's at the speed of my network and my RAM. Now, in order for me to keep that up and running, though, because the main problem with RAM is that all that memory goes away when you either shut down the application or you shut down the computer. So all you have to really do is come up with some sort of hardware system that networks together different boxes that are nothing but RAM, that are just basically nothing but RAM. As soon as they fire up, all the applications are loaded right into the RAM, and maybe they pull that information from a network. There might be some minimal storage that's necessary in order to get the system up and running. But as far as what is running, once it is up and running, it's all in memory. It's all RAM. And while it's all RAM and while it's all memory, it makes it easier for you to access. And then if you have this redundant system, so that if something happens to that system and it gets shut off, or the application drops, or that hardware fails in some way, then it immediately can be branched over. We have a failover, and another system kind of comes in and takes its place. And this is the type of technology that's already, it's been, for a while, they've been working on stuff like this. I just haven't seen it happen in a way that is a full-fledged, cheap, inexpensive solution that companies have been willing to spend the money to make this kind of system happen. So I do think that there is some room there for, in the next 5 to 10 years, for data services to really be managed that way. The second thing that I'm going to probably say is that quantum computing is going to revolutionize the way that we store and run our data. You can imagine that once we no longer are restricted to having ones or zeros, okay, now we can do multiple different storage. So like right now, you have to have multiple bits, right, in order to make up a byte. It takes 8 bits to make up a byte, and that one byte is basically a character. Well, imagine not having that 8 bytes, okay, or 8 bits to make up a byte. Imagine having, you can store whatever character you want, and that's just one piece of data. That increases the speed and effectiveness of your storage and your memory by a factor of 8 alone, just right there. And there's other techniques that they're coming to with quantum computing that I just think are going to blow us out of the water. And it is a real legitimate technology. It's expensive to do right now, but in the future, if we're talking 20, 30 years, I think quantum computing is probably going to dominate the way that we do technology. The last thing I'm going to talk about and bring up here is that for the most part, I think we've all seen that there's a limit to the technology that we have as far as making things go faster. No longer are we, well, let me just go to like the chips, the CPU, for example. We have CPUs that back in the day, you had one CPU with one core. And heck, before that, there was not even that. But we have CPUs that have one core. And what they did was they kind of started to get to a limit of how fast that one core could process information. So how did they fix this problem? They ran into the ceiling for how fast it could go. Well, they just added more cores, right? That's all that they did. You got the core, like the Intel Core 2 Duo or something like that. Now you got 4 and you got quad cores and 8 cores and 16 cores. And I mean, it just keeps getting bigger and bigger, but you just keep expanding on the cores. You just keep adding more cores. And this is actually where functional programming has started to come into needing to be around, is because it can handle multiple tasking across all these different cores. All right, when you have just straight 32-bit operating systems, they can only basically run on one core. You can't run it across multiple cores, and you can't have things like tasks and stuff like we have in C#. If you're just running it off one core, it doesn't make any sense to try to do this splitting up of your tasks. So this multi-threading, that was the word I was trying to come up with, multi-threading. You couldn't do multi-threading in 32-bit, but now you can in 64-bit, and that's because we have multiple cores. And there needed to be some way for us to do programming where we could send different streams of our code to be processed not from one core, but from multiple cores. And that's why we have functional programming. That's why functional programming is such a big concept in today's world, is because we have to be able to have our code run across all these different cores. So with that in mind, I think that is an area that SQL itself is not really going to be able to do anything with. But we've reached a limit with the way that the technology, the speed at which individual cores can go. And so the way that we store and retrieve data is going to change as far as the back end, the way that they code it up to go do the data retrieval. Because transaction logs are great, but now that we have to do multi-threading, I don't know. I don't know what kind of impact the transaction logs are going to have with that multi-threading. So we're going to see. We're really going to see. Once we get to quantum computing, which is, again, way off in the future, I think that's going to be remarkable. For kind of the immediate future, I think that there needs to be a fixing of the way that our code bases work in our SQL database management systems, because now we have multi-threading. With the 64-bit, it's kind of a relatively new technology to SQL. So I hope to see more inroads with that. When it comes to, storing RAM versus storing on disk, I really hope to see more just hardware that boots up, like operating systems that just boot up to RAM, and that's like everything. And you have no hard disk space access at all, except for just to kind of load up the necessary bits and components to get loaded up into RAM, but none of the actual storage. So it's kind of like a metadata system, right? You're just storing the structure, your schema of the application, or the schema of what should get mapped to memory. And then once it goes, then it's always open. And then as long as you're sending information to it, it's going to store it in the memory and kick it back out. But then once you shut that system off, it's going to drop, right? So all you have to do in order to load that memory back up after a reboot of the system is it pulls back up, grabs the information from one of the failovers, and now it's back up online. I think that's a very simple solution to making SQL run a lot faster, is to have it move to RAM. Whether or not they're going to do that, though, I don't know. Because like I said, they've got a lot of tooling right now in order to make SQL go faster and have really good performance right now. So why would they really need to go into something that complex unless you're talking about, you know, if you're talking like Amazon or eBay or some places like that, Google, where you have just such a monstrous amount of data, I think then it makes a lot of sense to have a structure like that. And that's why we see some inroads in that type of way of doing your computing and storing your information. They're really looking for solutions, right? Google and Amazon have problems with how they're storing and managing their data. So those are the type of solutions that they're thinking about. But for most of us, SQL is a perfectly fine and ordinary and great example, great solution for us. The SQL language is so ubiquitous across all the different platforms that, it makes it easier that once we learn it, we know it, and it's not going to go anywhere for a long time. I don't think SQL is going to go anywhere. So there you have it. I've gone on for I don't even know how long now about this topic. So Benjamin, thank you so much for your question. If there's anything that you'd like a bit more in-depth discussion about, please, again, drop me a comment in the comment section below. And, as long as it's a good one and I've got time to go do the research, I will do it and I'll bring it back to you guys, okay? So thank you so much for watching, everybody. Until the next time, have a great, wonderful day. Bye-bye. I'd like to give special thanks to James McCoy, whose kind and generous donations have made this video possible. If you would also like to contribute, please visit us on patreon.com/programmingmadeeasy.